Hi everyone, welcome to the day 16 of our 24-day series of Microsoft Fabric. So today we are going to create our first machine learning model in Microsoft Fabric, and we will use the data sets which we created in our previous videos, and we will use the same data sets only. So let's start. So first of all, let me create a notebook, and I'll use this as a first ML model notebook as name. Okay. So in our previous video, we cleaned the data, explored it, and created features. So now comes the most exciting part, which will be the ML, machine learning. And today we will train a model that can predict sales revenue using Microsoft Fabric. So here I need to add the data set source. So I'll load the existing Lakehouse, which we are using in our previous videos. So now we have to load our feature data set from the Lakehouse. So just a second, I'll write it here as a load feature data set from Lakehouse. The feature dataset which we already cleaned in our previous uh, videos. So you know how we can load it spark.read.table, and we have to provide the table name. So our table name was, let's see, the table name was sales underscore features. Okay, sales underscore feed TURES. So basically we have done uh, the feature engineering part in our previous video, so you can check our previous video. Now let's run this. Let's see the data. First, it will create, because it is the first run of this notebook, so it will create a standard session, and then after that it will read the table, then it will show the data from the table. Okay, because so why we are using a feature table? Basically, in real projects also, we never train models on raw data. So first of all, we have to transform the data, and we have to clean it. We have to create it for ML ready. In our previous video, we saw how we can create our data set to feature ready. So that's why we always use a feature table. Now, to define to test our ML, so first we have to define our target variable. So which we can say as a label, because ML needs an output. Okay, so machine learning needs one column to predict, and that column is called as a label. Okay, so in our case, the label will be revenue, and the features will be quantity, price, region, product, date, and fee. Okay, these will be our features. So we are predicting the revenue, so revenue becomes our label. Okay, now what we have to do? We will assemble the features. So Spark ML model don't understand multiple columns. So what we will do? We will create again one feature vector. In our previous video, we have created some feature vector columns. So again here we will load from PySpark.ml.features. Okay, we have to import vector assembler. Okay, now with the help of this assembler, we will assemble all our related columns. So let's see, assembler equals to, and we have to provide the input columns. So the input columns are, so we have multiple input columns. So we'll start with quantity, then we have a unit price. Okay. Then we have region index. Okay. Then we have the product index. Fine. And we have order month and order day of week. Order underscore month. Then we have order day of week. Order underscore day of week. Fine. So these will be our input columns, and for our output column, what we have to write is features. Okay. So sorry. Here after this list, I need to provide an output column. So output call will be, I'll name it as features feature. Okay. Now let's catch it in our final df. So final data frame. So I'll write final underscore df equals to. So here we will use the assembler dot. We will use transform df. So we will transform our df based on this assembler, and now we will only select final df say the feature and the revenue. Okay, so final df dot select, and we will select only the features, features features comma revenue. Okay, and dot show. Let's run. Taking time to assemble those. Oh, okay. So here you can see these three dots are coming now. So how you can ignore this? You have to write it here. Truncate equals to false. Okay. Truncate equals to false. So basically the truncation of data here happening. Now it will not happen. Okay. So you can see all the columns like quantity, unit price, region index, product index, order month and day of week. Everything will be here. Okay. And then the based on that revenues. Okay. Now we have to split the data part to train it and test it. Okay. So basically, if we train and test on the same data, the model will cheat. So we should split the data. So let's do one thing. Let's create a train df, train underscore df, comma test df. Okay. Train df and test df both. So split, let's do split of 80-20 will be fine. Okay. So we'll use random split, and the split we will give it as 0.8 comma 0.2. So it will be 80% and 20% split between the train and test. Okay, and let's provide the seed as 42. Okay, let's run this now. Because this is a numeric value data, and here you can see this is a numeric value data. So now we have to choose our ML algorithm. So for the numeric data, the best algorithm in ML will be the regression problem. Okay. So this is a regression problem. So let's start with, so from PySpark and .ml.regression. Okay. We have to import the linear regression. Okay. Linear regression, only the linear regression. Okay. No, let's name it as LR equals to we have to write linear regression, and the feature column will be features column will be our features, and label column will be our revenue. Okay, feature featu res, right, and our label column will be revenue. Label call will be revenue, right? Okay, let's run this. So basically, linear regression is simple and explainable, and it is very perfect for beginners who want to create a first ML model. So it ran. So now we will train the model. So we will use LR underscore model equals to. So for the same LR, what we will do, we will use LR dot fit, and we will train it with the train DF we have. Okay. So first we will use the train DF, which is just 20% of, no, it is, I think, 80. Yeah, 80% of data splitted here. So we will train that. So the model learns the relationship between the inputs and the revenue. That's what training called. Okay. Now we can use the predictions. Now let's predict it, let it run. So we will make predictions. Okay. And prediction is what the model think the revenue should be for the future. Okay. Let it run. Okay, it ran. Now write first the predictions. So let's predict predictions equals to our LR underscore model. What we will do, we will transform it the test DF based on this. So we will use the test DF here. Now let's see our data after predictions. So let's do predictions dot select. We need only revenue and prediction. Okay, revenue comma prediction. PREDICTION. Let's do it dot show. So the next prediction is revenue was 35. The next prediction is 57,444. So prediction, as I told you, prediction is what the model think the revenue should be. Okay. Now let's evaluate the performance, model performance. So without evaluation, we can't trust a model. So let's evaluate the predictions. Okay, the performance. So let's write from PySpark.ml.evaluation. Okay, PySpark.ml.evaluation. Okay, and we have to import the regression evaluator. So we have regression evaluator. Now we will use it. So we will use evaluator UA POR evaluator equals to. We'll use the regression evaluator. Then the label column was, what was the label column? It was revenue. Okay, right? So revenue, and the prediction column was, sorry, prediction column was prediction only. PREDICTION, prediction. Okay. And the metric name is, what is the metric? Let's write some random metric name. Goes to RMSE. Let's write RMSE. Okay. So RMSE, where there we will catch it. So let's RMS equals to evaluator, and so it will evaluate the predictions. So predictions, right? Let's see the RMSE. Let's run. So RMSE tells us how far our predictions are from the actual values on average. Okay. So our okay actual values. So the values are 22,444 far. So okay. So let's interpret the model. So what we will do, we'll write LR underscore model dot coefficients. Let's run this. So so these coefficients tell us why the features influence revenue more. Okay, these are the coefficient of the vector dense vector. So this is why linear models are popular in business. Okay, so it is okay. So now let's save the predictions. So how we will save? So let's write predictions score. We will save it in our uh, Lakehouse. So what we'll do, we will again write it back. So we will write it in the Lakehouse as the mode of overwrite. And again here we will use save as table and the table name little sales predictions, right? Sales underscore predictions. Let's run this. It will save. So now those predictions are stored in Lakehouse and can be used in our Power BI. Okay. So today what we have done here, we built a machine learning model. So we predicted the revenue. And what we do, we evaluated the model performance and we stored the predictions for reporting. So this is the complete ML cycle. We use the regression model. Okay. And what we did, we predicted our revenue based on our feature columns. And in our, so this is for today. So in our next video, we will track this model using ML flow and we will compare multiple models and then understand the model versioning in Microsoft Fabric. Okay. So thanks everyone. Thanks for watching our session. Let's connect again. Thank you. Bye bye.